Okay guys, welcome back. We're going into section 4A. We're going to be factoring today. You guys have been doing this stuff since ninth grade, Algebra 1 and Algebra 2, and we're hitting it a third time for Algebra 3. Factoring is very important in algebra. So let's go over the first way of factoring, which is terms with common factors. We know this as greatest common factor. That is the number one way that we always look to factor GCF first. Always, always, always. So when factoring a polynomial, we factor out the factors that are common to all terms. So in example 1, it just says factor, so we need to observe always and go, do I have a GCF here? So you have three terms. Remember, terms are separated by plus and minus signs. So in this case, you want to look at the regular numbers first and then worry about the variables. Now, 15, 10, and 5, is there a number that multiplies into all three of those? Absolutely. That number would be 5. That is what we call the greatest common factor. Now, should an x go with my GCF of 5? That answer would be no. The 15 does not have an x, so your GCF is just 5. Now what we need to do is a GCF goes outside of one parentheses. And remember that factoring is dividing up into smaller parts, so we need to divide every term by 5. So 15 divided by 5 is 3. Plus 10x divided by 5 is 2x, and then minus the 5's cancel here, bring down your x squared, it's 1x squared. Okay, let's try another one. What is the GCF of 12 and 20? Now, if you said 2, you'd be half correct. It's a common factor, but it is not the greatest common factor. So what is the biggest number that multiplies into 12 and 20 evenly? That would be 4. So our GCF starts off with a 4. Now we look at the variables. The variable, we have two terms here. I see an x in both of those. So that means an x must be in my GCF. In fact, it's going to be x to the second power. The rule for exponents in a GCF is you take the smallest exponent. So if I had x to the second and x to the third, you go with the smallest. And then the y's, you have y to the second and y. So you would choose the smallest, which is y. And now we put our one parentheses, and we need to divide to see what's left over in the parentheses. We divide each term by the GCF. So here, 12 divided by 4 is 3. The x's are identical. X squareds are identical. They cancel out. And then y squared divided by y is y. Minus 20 divided by 4 is 5. X to the third divided by x to the second is x. Remember, we're subtracting the exponents when we're dividing. Then the y's are identical. They cancel out there. So that problem is done. Okay, next up is something called factor by grouping. This was not in Algebra 1, I don't think, but it was definitely taught by me in Algebra 2. So factor by grouping is when you have 4 terms in your polynomial. So as you can see in A and B, we have 4 terms in each problem. Now, I do want to give you guys a heads up. I serve as kind of a guide. I don't have a lot of examples. I don't have a lot of steps written down when I go over my lessons. So feel free, if there's anything you want to see more of, go hit up YouTube and say, like, if I show these 2 problems on factor by grouping and you're still confused afterwards, you got to be accountable and go into YouTube and type in factor by grouping and watch some more stuff on it. Okay, so in some polynomials, pairs of terms have a common binomial factor that can be removed in a process called factor by grouping. Let me show you what I mean by this, because that was a little wordy. So what you do, factor by grouping means make two groups. And then what you're going to do is GCF to, let's say GCF twice, 2 times. So your first group, we need to think, what is my GCF of my first group? Well, the only thing common to both of those terms is x. And as I've stated already today, you go with the smallest exponent, 2. And then now we need to divide by x to the second to see what's left in parentheses. X to the third divided by x to the second is x to the first, plus 3 carries down, and then the x squareds cancel. Now we move on to the second group. So what's my GCF of negative 5x and negative 15? Well, if you said 5, you'd be really close. It's actually negative 5. When you have your first term here, when you're doing a GCF problem and your first term is a negative, you're supposed to have a negative in your GCF. So negative 5 is what I'm going to be dividing by, because that's my GCF. And we got to be careful with sign rules. So negative 5x divided by negative 5 is x. Then negative 15 divided by negative 5 is 3. So put a plus 3 because it's positive. I want you guys to notice something here. Look at those parentheses and see how they match. That means I did this correctly. And factor by grouping, after you GCF twice, what's in your parentheses should be identical. And that means we can move on to the next step, which is the easiest thing ever. We are going to just regroup into 2 binomials here, into 2 parentheses. You'll notice it is the one group. The x plus 3, I only write it once. Okay? What I highlighted in orange, I only write it once in my answer. And then where'd that x to the second minus 5 come from? That came from my GCFs that I took out. I put them together in the other set of parentheses. Much easier than it looks. Okay, let's try another example. We have 4 terms, so we're going to make our 2 groups. And what is the GCF of the first set of parentheses? It would be, well, 10 and 5 would definitely be 5. And then an x would have to be part of it too. X is with both of those numbers, both of those terms, and we choose the smallest, so just an x. And then we need to divide both sides by 5x. So 10 divided by 5 is 2. X to the second divided by x is x. Then plus. Now, you'll know 5x divided by 5x. Remember, anything divided by itself is just 1. Some people will actually go cancel, cancel, and then they'll put leave a blank there. But remember, when you're dividing and things cancel out, it's 1, not blank. And definitely not 0. Okay, now your second group, what's your GCF of 4x and 2? You would say 2. So put a plus 2. You don't leave a blank, like you would not just leave it like this, okay? If it's a 2, make sure, and it's in between, put a plus 2. We don't leave blank gaps open in polynomials. And then we're gonna divide by 2. So 4x divided by 2 is 2, then x, plus 2 divided by 2 is 1. Notice something again here. My parentheses match. That means I'm doing this correctly, and it's time to go to our answer. So in my 2 binomials, you're matching 2x plus 1, just write it once, and then what will go into your other set of parentheses? Your GCFs get put together, 5x plus 2. Okay, next up, the third and final way of factoring of the day is difference of squares. You will notice that all of these problems that you see here each have two terms, or they are binomials. They must have a minus sign in between. So in this special case, you will, or this is a special type of factorization that uses a pattern called the difference of squares. You'll notice that in order to be a difference of squares, they have to be numbers that are squares or square rootable numbers. For example, 1, 4, 9. I'm writing down the what we call squares in math. And these numbers, when you take the square root of them, get 1. Like square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, and 6 and 7 and 8 and 9 and 10. All right, so you'll see a pattern there. So for example, in x squared minus 16, you go and you make 2 parentheses. Your x squared turns into x and x. What we're really is splitting up the x squared into x and x. Think dividing. Our signs for difference of squares are always plus minus. And then what do we do with the 16? A lot of people accidentally divide it by 2 and put 8s. No, you need to take the square root of it, and square root of 16 is 4. All right, letter B is another difference of squares. It's a binomial with a minus sign in between, and both 9a squared and 25 are square rootable. So we're going to go to 2 sets of parentheses. My signs are always plus minus for difference of squares. The square root of 9a to the second is 3a, and the square root of 25 is 5. Okay, letter C is actually a little bit of a curveball they try to throw at you. This really jumped up in difficulty here. Now, you might be thinking, well, 6 is not on that list of perfect squares, and you'd be correct. Sometimes we actually have to, let me back up a bit. Earlier in the lesson, I said that GCF is always number 1. Whenever I give you a factoring problem, you should always be on the lookout for GCF first. Do I have one here? Yes, I do. I actually have a GCF of 6. So then, when you factor out and divide 6, you're left with x to the 4th minus y to the 4th. Now, you might be thinking, that still doesn't look like the others that you just did. Well, I did say this was going to jump up in difficulty, which it did. Believe it or not, this is actually a difference of squares, if you ignore the 6 now. So let's just bring down the 6 for a second. And this is difference of squares. We have a binomial, and we have a minus sign in between, hence the term difference. And any exponent that is an even number is square rootable. Now, when you square root an exponent, you're actually dividing it by 2. So the x to the 4th is going to become x to the 2nd and x to the 2nd. The square root of y to the 4th is y to the 2nd and y to the 2nd. And then your signs are always, what are they for difference of squares? Your signs are always plus minus. Now, believe it or not, we can actually factor more. I said this does get difficult. So this guy right here, this third one, is actually a difference of squares again. So it has a binomial with a minus sign, and the exponents are even, meaning they're square rootable. So that third, or that last parentheses there, can be split up further. X squared gets split up as x and x. The signs are plus minus, and the square root of y squared is y and y. Now, a lot of people think, if you look at this one right here, a lot of people think that's a difference of squares also, but it's actually not. The reason it's not a difference of squares is because there's a plus sign in between. So not difference of squares, so that actually, along with the 6, that drops down. And there's my answer. Okay, guys, that's it for my lesson. If you need to, I encourage you guys to watch more YouTube videos on stuff we've done today, if it's a little confusing. So the first thing we did was GCF of polynomials. The second thing we did was factor by grouping. And the third thing we did was difference of squares. So when you're ready to go right ahead and hit up the assignment that comes after it, which is assignment 4A, those 15 problems. All right, guys, be good.